From the massive visual effects and blockbuster films, to the architecture of your local mall, and even the broadcast graphics on the evening news, 3D content is everywhere you look. But creating those immersive digital experiences used to require navigating incredibly dense mathematical software. This created a massive wall between an artist's creative vision and the technical execution required to actually pull it off. That gap is exactly what Cinema 4D was built to close. First released by Maxon in 1990, it was designed to bridge raw computational power with natural artist intuition. The software operates on a dual nature. On the surface, it offers a streamlined interface. Under the hood, it's driving enterprise-level, highly complex creative tools. By lowering the barrier to entry, Cinema 4D made high-end design accessible to hobbyists and professionals alike. It gave artists the tools to bring their ideas to life without getting bogged down in code. To understand how this works, we have to walk through the production pipeline, starting with step 1, opening a new project and stepping into an empty, infinite digital void. Artists used procedural tools to stretch and manipulate points on basic mathematical shapes, constructing complex geometric structures. This grid then simplifies to show polygon optimization. Without managing this count, complexity overloads memory and crashes the software. Once the geometry is stable, the model needs a surface. This introduces UV mapping, a technique where flat, two-dimensional images are precisely wrapped and translated onto those complex 3D contours. By applying these specific materials and texturing layers, creators can mimic how light interacts with physical properties, giving a digital model the roughness of concrete or the high-gloss shine of polished chrome. These shaping and painting phases successfully take a mathematical void and turn it into a tangible, recognizable asset. Now it's ready to move. This brings us to Cinema 4D's signature capability, the MoGraph module, a specialized toolset designed to generate dynamic motion graphics. This diagram shows how MoGraph uses procedural tools like cloners and effectors. An artist can take one simple block, instantly multiply it by the hundreds, and drive them all in an elegant mathematical wave. To achieve true realism, the objects must react to their environment. The software's dynamic simulations calculate real-world variables, determining exactly how objects fall under gravity or shatter during a collision. To mimic complex organic matter, Cinema 4D uses highly specialized systems. You can calculate the behavior of individual hair strands catching the wind, or watch how a heavy stone naturally ripples a digital silk fabric. It even includes advanced character animation tools, allowing creators to map lifelike muscle movements and facial expressions onto rigged human or creature models. Together, these motion and simulation tools act as the engines of realism. They drop a static, painted model into a living scene that obeys the laws of physics. With the scene built and moving, we enter the virtual shoot. This is where artists arrange digital lighting setups and frame their high-quality camera angles to capture the action. Behind the scenes, managing all these overlapping lights, textures, and physics rules gets incredibly complex. To keep it organized, artists use node-based workflows, a visual, logical mapping system that connects all the moving parts of a project. This chart shows the primary production bottleneck. As you increase polygon count and lighting complexity on the x-axis, the required rendering time on the y-axis spikes exponentially, creating a massive hardware demand. To tackle these intense computational requirements, studios frequently integrate advanced external rendering engines, like Redshift or Octane Render, to optimize performance and speed up the output. This rendering phase is the critical final threshold. It is the moment where billions of raw geometric data points and physics equations are permanently baked into the photorealistic imagery we see on screen. The final export rarely sits in isolation. Cinema 4D often serves as a single node in a larger production ecosystem, integrating with software like Adobe After Effects for final post-production compositing. Creators can also export those fully rigged 3D assets directly into major game engines like Unreal Engine and Unity, allowing for real-time interactive rendering in video games. Looking ahead, the creative workflow is accelerating. AI-assisted content creation and next-generation GPU rendering are cutting down the time it takes to build and calculate these massive digital environments. We are seeing these optimized tools applied to everything from real-time virtual film sets and immersive AR and VR experiences to building exact digital twins of real-world factories and cities. By wrapping extreme technical complexity inside an accessible interface, Cinema 4D gave creators a clear path to execution. This shift democratized world building, placing the power to shape the digital future directly into the hands of artists.